Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework tonight. Tonight we're looking in Math 1, Worksheet 8.3. Remember, if you have a problem with one particular problem, fast forward to that problem and we should be able to help you out. So let's get started. Our first problem asks us to plot the image of this segment SR after a 90-degree rotation. Now, we know from our notes that the rule for this is that xy becomes minus yx. So they switch and the y becomes opposite. If you're not quite sure why this works, let me give you a little demonstration here. Let me draw a little triangle here that is over 2 and up 3. Now what happens if I were to rotate this 90 degrees is that what I end up with is a triangle that looks like this. And you'll notice with the rotation 90 degrees, what happened is the positive 2x became a positive 2y. So the x became a y in the y position. But the 3 here goes from a y to an x, but becomes negative. So it's negative 3, negative y. And that's just kind of visually what's happening when we do that. Now to do this for your sake, you just need to remember this rule. XY becomes minus YX for a 90-degree counterclockwise. And so we put in our first point. S is minus 3, 1. So we switch them and make the Y negative. So negative 1, negative 3. And that becomes our point down here, S prime. And the same with R. 1, 4 becomes minus 4, 1. And then we draw our line. Last point asks for the slope. Well, I notice if I draw a little slope triangle, it goes down 4 and over 3, so my slope is minus 4/3, which is the opposite of the original one here, which was 3/4. So these actually, the 90-degree turn, notice, makes two lines that are parallel to each other. Perpendicular to each other. All right, so this one asks us to plot this segment after 180-degree rotation clockwise around the origin. Once again, our rule for that is xy becomes minus x minus y. If I tried to show you that graphically, it would look something like this. If I draw a little triangle here, notice it goes over 2 and up 3. But on the other hand, if I graph that and pull it around 180 degrees, then I end up with something like this. And if you notice the graphing all the way around like that, my 2 now becomes a minus 2, and my down becomes a minus 3. And that's the nature of the 180. But let's plug in our points here now. Notice our points here. S is minus 3, 1. So we just switch that, the opposite of that becomes 3 minus 1. And so that's the point over here. And then for T as well, 1, 4 becomes minus 1, minus 4. And we connect those, and there we have it. Our slope, notice, if I do the slope from there, is up 3 and over 4. So the slope is 3/4. Our third problem asks us to take the same segment and go 270 degrees counterclockwise. By the way, if you're wondering, this is the same as going 90 degrees clockwise. In other words, if I'm here and I go 90, 180, 270, notice that's the same as if I start that counterclockwise as if I just went 90 degrees that way. So just to kind of note, if you ever have somebody say, well, I want you to go 90 degrees clockwise, you can use the same rule as 270. Now, the rule we discovered was similar to the 90 degree, except this time the x and the y change, but this time it's the x that becomes negative, okay? So let's put in the numbers here for this. Negative 3, 1, now we switch them around and have 1, negative 3, but now it's the x that switches, so the negative 3 becomes 1, positive 3. So we have 1, 3. And then likewise for R, 1, 4 becomes 4 minus 1. And there is our rotation. Notice again, the slope is down 4 over 3, which makes it exactly the perpendicular to SR, which was 3 over 4. So these two lines are actually perpendicular. Problem 4 is a relatively simple problem. It asks us to take this triangle with the following vertices and rotate it 90 degrees. We don't even have to draw it. So all we're going to do is use our rule that says xy goes to minus yx. And the process for this is really relatively simple. What I'm going to do in each case is I'm going to take xy, and the first thing I'll do is switch them to y minus x, and then I'll take that and take the opposite of it. Okay? So let's look at our first number. I'll show you how this works. So I have the number 3, 2. So the first thing I do is swap them, 2, 3, and then I take the opposite of that one, and I have minus 2, 3, and that's my answer. Same thing with the next one. I have minus 4, 6. So first thing I do, just swap them, and then take the first component and take the opposite. So I end up with minus 6, minus 4. And likewise on the last one, I have 1, minus 7. So let's swap them first, minus 7, 1, and then take the opposite of the first variable. So I end up with 7, 1. And that'll be the vertices of the new triangle, rotated 90 degrees counterclockwise. Number 5, we're going to take a triangle and rotate it 180 degrees. Again, remember our rule. This one's fairly simple. X and Y just both become opposites. All right. So you just simply start with an XY, and this time take the opposite of both of them, minus X, minus Y. Here's how it works in practice. Here's my point, minus 2, 3. So the opposite of minus 2 is 2, and the opposite of 3 is minus 3. That's my point. Next point, 0, 0. This one's interesting because what's the opposite of 0? 0. Opposite of 0, 0. In other words, this one doesn't change at all. You're rotating around the axis. Well, this is actually the origin, so it doesn't change at all. And the last one, 4, 2, 4 minus 2. The opposite of 4 is minus 4, and the opposite of negative 2 is positive 2. And so there are the 3 points when I translated 180 degrees around. And number 6, we have a triangle that we're going to rotate 270 degrees. Remember the rule for this one? Similar to 90 degrees, except we take the opposite of x this time instead of y, is I'm going to take any number, x, y. First thing I'm going to do is swap them. And then now I'm going to take the opposite of the x. So I end up with y minus x. So here's how it works in practice. Here's my point 0, 4. So I switch them. And then I take the opposite of 0. Well, in this case, the opposite of 0 is 0. So the answer is just 4, 0. Move to the next point. I have 5, 0. Switch them. I have 0, 5. But now the opposite of that one is minus 5. So this point is 0, minus 5. And then finally, this one is not a surprise. 0, 0. Switch them, it's still 0, 0, and the opposite of 0 is 0, so that one doesn't change at all in the rotation. In problem 7, we're going to do what we did earlier. We're going to take the points using this rule, and remember the rule for 180 is you just take the opposite of each of them. But we're going to do that and then actually use it to plot. So notice my first point, minus 2 becomes positive 2, positive 2, so I can plot that point there. I is 1 minus 2, so the opposite of 1 is negative 1. The opposite of negative 2 is positive 2, so we'll plot that point there. And then the point G is 1 minus 3, so the opposite of 1 is negative 1. The opposite of negative 3 is positive 3, so my new point is G prime there. And then lastly, B is minus 3 minus 4, so the opposite of each of those is going to be positive 3, positive 4. So I got my point here, and now I just draw my diagram, and I've rotated that 180 degrees about the origin. Number 8, we're rotating this quadrilateral 90 degrees about the origin. So this is one of those, the 90 and 270, where we flip the x and the y and make one of them the opposite. In this case, we flip x and y and we take the y term and take the opposite of it. So my first one, notice here, and I'll just kind of do it here so you get the pattern. If I have minus 3, 5, I switch them to 5 minus 3, but then I take the opposite of the first one, so I end up with minus 5 minus 3. And we plot that point here, t prime down there. The next point, G, is 0, 5, so I switch them, 5, 0, and the opposite of that is going to be minus 5, 0. So there's our next point there. And then our next point, C, 2, 3, switch them, 3, 2, and then take the opposite of that one, so I get minus 3, 2 is my rotation there. And then finally, minus 3, 3. I switch them, becomes 3 minus 3, and take the opposite of that, so I end up with minus 3 is my point. Plot that point. And then there's our rotated 90 degrees about the origin. Problem 9 is an interesting question because it asks us to rotate this triangle 90 degrees about a point different than the origin. All right, so I want to show you how we can do this. First of all, there's our point right here, minus 1, 2, and here's the points on our triangle. And what I'm going to do first is I'm going to pretend like I'm just translating the whole thing so that I rotate about the origin. So I'm going to say to get to here, I go down 2 and over 1. Well, if I translated my triangle down there, down 2 and over 1, it would be like adding 1 to x and subtracting 2 from y. So notice if I just add those to each point, my translation would be 2, 1 and 4, 2. So what I'm doing is translating everything down 2 and right 1. Now I'm at the origin now. So now I can use my formula for rotation. So I'll rotate 90 degrees, which means xy becomes minus yx. Switch them and make the x coordinate the opposite. So 2, 1 becomes minus 1, 2. 4, 2 becomes minus 2, 4. And 6, 0 becomes 0, 6. But now, because I wanted to do this at this point, I'm going to reverse the translation and translate back. So instead of adding 1 and subtracting 2, we're going to subtract 1 and add 2. So notice this is the opposite of this. So I translated down to this point. Now I'm going to translate back to that point. And when I do, I end up with minus 2, 4. And again, I'm adding these two together here. Just like up there, we added these two. Adding those two together. And there's my new points. And then I plot those points. P prime, W prime, and H prime. And to show you that it worked, I'll use kind of a graphical way to show if this were my triangle from this point, notice 2 over and 1, and I just rotated that 90 degrees, see that triangle would move into there, and notice that P maps onto P prime to show you that this method works. So we translated from this, the new origin point, the point of rotation, translated that down to the origin and the whole triangle, rotated it, and then translated it back. Problem 10 is very much like problem 9. Instead of 90 degrees, we're going to rotate 180 degrees. However, we're going to rotate about a point, not the origin. So again, our strategy, first let's translate the triangle so that our rotation point is the origin. Do the rotation, and then translate back. That's our strategy. So the first thing we're going to do, there's our point 2, 1. So to get to the origin, notice that I go back 2 and down 1. So the first thing I want to do is take my point here and move it left 2 and down 1. So the x is minus 2, the y is minus 1, and add those together. And you notice all I'm doing is adding these points together. So 1 and minus 2 is minus 1, minus 4 minus 1 is minus 5. So now I've made it so that I'm rotating about the origin, and now I can use my rule that 180 degrees, xy becomes minus x minus y, and just simply take these and rotate them. So minus 1 minus 2 becomes plus 1 plus 2. 2 minus 2 becomes minus 2 plus 2. And minus 1 minus 5 becomes 1, 5. The next step then is to translate it back to the original rotation place, which means I'm going to do the opposite of what I did here. Okay, this was minus 2 minus 1. So here I'm going to do plus 2 plus 1. And now we'll add these together. And notice I'm adding, again, these two together here. So notice 1 and 2 is 3, and 5 and 1 is 6 across the line. And there's my 3 new points. So let's plot them. 3, 3, 0, 3, and 3, 6. And there's my new triangle. And to show you how that worked, if I took one of these points like F, do a little triangle up to that point, but then I rotated it around 180 degrees, you see I end up at F prime, just to kind of show you that that works out. All right, I hope that helps you with your homework. Have a good evening.